So for this first example, we are going to be solving linear equations. Now keep in mind that a linear equation, as we have right here, that eventually we're going to start graphing these equations. And when we graph them, they make a pictorial representation of what this equation represents or what an equation represents. And for these particular types of equations, the graph is going to be a line, thus the term linear equation. And of course it says determine the solution to the linear equation. We have 5p minus 4 times p plus 2. That's equal to 2 minus p. Now a solution, we solve equations. Obviously we have an equal sign in here. This makes it an equation. And what that means, the solution is we're going to find a value for the variable. And in this case the variable is p. So that when we use that variable, it makes this equation a true statement. So the first thing we're going to do is I'm just going to rewrite this equation here. 5p minus 4 times p plus 2. That's equal to 2 minus p. And one of the first things that we're going to do is we're going to get rid of these. I like to call them like these little barriers. Obviously, these are parentheses. But we're going to get rid of these little barriers, and we're going to use the distributive property to be able to do that. So this is going to be 5p. Then we have negative 4 times p, so this becomes minus 4p. And then negative 4 times 2, that's negative 8. The distributive property says we just take this value and we multiply it to each term inside the parentheses here. And of course that's equal to 2 minus p. So now that we got rid of the barriers here, the parentheses here, we can go ahead and we can collect up like terms that are in common. So I have 5p minus 4p. 5p minus 4p is p, so I'm left with p minus 8. That's equal to 2 minus p. Now since I want to know what p is, we're going to get p all by itself on one side of the equal sign. So I'm going to use the addition property of equality, and I'm just going to add p over here. And what that says is that what you do on one side of the equal sign of an equation, you must do it on the other side. So I'm just going to go ahead and add p over here. So over here we have 2 minus p plus p, and the whole idea is that then these two are going to cancel. That's the objective there. P plus p, that's 2p, so we're left with 2p minus 8. That's equal to 2. We'll do the same thing. We want to be able to get p alone here, so I'm going to get rid of this term here. So I'll add 8 here. Again, we got to do the same thing on the other side of the equal sign. 2 minus p plus p. Those terms will cancel. Again, that's the whole idea. So I'm left with 2p. That's equal to 2 plus 8. And of course, 2 plus 8 is 10. Again, to get p by itself, I need to get rid of the coefficient here, 2. So we could either multiply both sides by the reciprocal of 2, and that would be multiply both sides by 1/2. Or we could simply just divide both sides by 2. 2p over 2, again, those factors are going to cancel. So I'm left with p is equal to 10 over 2, and 10 divided by 2 is 5. So if this is the solution, if p does equal to 5, then if we were to use it in here, it's going to make this a true statement. So that's what we'll do. We'll check it. We'll go ahead and we'll plug it in. So I have 5p, and what's p? P is 5 minus 4 times p, which is 5, plus 2. That's equal to 2 minus p. And of course, that's 5. And now we could just go ahead and we could do the arithmetic. 5 times 5, that's 25. 5 plus 2, that's 7. So I've got minus 4 times 7. And that's equal to 2 minus 5, and 2 minus 5, that is negative 3. 25 minus 4 times 7. 4 times 7 is 28. 25 minus 28. That is indeed equal to -3. So -3 equals -3, which is a true statement. So since that's a true statement, then P equals 5 is the solution to this linear equation. And there we have it.